This is webinar 8 or webinar 9?
This is webinar 9. We are live.
Very, very good afternoon. Good morning to those who are in this part of the world. Good evening to those who are in this part of the world. And good evening to those who are on the side of the world, which is 6, 7, 8 o'clock. You can grab a glass of wine later and enjoy the webinar in a little bit more jovious fashion. Welcome to our today's webinar on daylighting and managing glare. We are extremely delighted to have a super gentleman and a great speaker from Chennai, Mr. Raghavendran. Padma Shri Ahad will talk more about it along with the other panelists who are on the panel today. I hope things are better in your area. You're staying safe. You're learning more effective time management. The fact that I see 300 people already on the webinar and we have 900 registrations, that still you are not sick of attending webinars. You're not saying webinar, oh my God, you're saying it's still okay. So I leave it to Ahad to take it on from me. Thank you very much.
Right. So, so good afternoon, everyone. Welcome to this 9th edition of the WFM webinar. So let me just get this sorted. Right. So today's topic is on daylighting and managing glare. This statement always appeals to me when I think of daylighting by Louis Kahn. Architecture appears for the first time when the sunlight hits a wall. The sunlight did not know what it was before it hit a wall. So I think this basically summarizes how daylighting and architecture are hand in hand, and how they need to be designed properly and synchronized together to have smart and sustainable buildings. Of course, daylighting comes by glass. Glass has been the one material which has probably revolutionized the construction industry. But there are also challenges with it. If you poorly design a glass facade, you tend to have excessive heat inside, which causes discomfort for our occupants. So I think today's session was basically to talk about daylighting and then how to manage glare. But we wanted to have it a little different. So we wanted architect C. N. Raghavendran, who I will introduce a little bit later, to talk his experience on what he has faced with designing buildings with glass, in managing glare, from his 40-50 years odd of experience. And then we wanted to present two solutions to you. One solution is a common solution, which is a structural louver, but with a twist. We wanted to, louvers are known to be more out of aluminium or terracotta or some other material, but we wanted to showcase louvers made out of high pressure laminate, which is again a sustainable material. And then we wanted to talk to you about present to you another solution, which is probably the future, which is dynamic glass. It is popular in few other parts of the world, in North America, but in India it has few installations but is picking up. So these are the two solutions we wanted to complement along with daylighting and managing the glare. So today's session, so we have a presentation by architect C. N. Raghavendran, followed by Balaji Chandran of FunderMax and by Ranojoy Dutta of View. We will then have a common Q&A at the end. Just to give you today's overview, so we have architect C. N. Raghavendran talking on daylighting and shading. He will give his broad overview and his experience of designing buildings and managing glare. Then we have a structural sun shading systems, which Balaji Chandran will present. And then we have dynamic glazing, which Ranojoy Dutta from View will present. Just to introduce our speakers, of course, architect C. N. Raghavendran needs no introduction, but I'll just run you through. He's a distinguished alumni of IIT Kharagpur. He has completed his architecture in 1966, and he's also finished his master's degree from UCL Berkeley in 1968. 2011, he was awarded the Padma Shri by the President of India, which is one of the highest civilian honors a person can get, and we're very happy that a person from the field of architecture has won this. He has a lot of other achievements to his portfolio. They run in pages if I have to read them, but these are his broad achievements. Next presenter is Balaji Chandran. He's the Associate Vice President at FunderMax. FunderMax is a leading manufacturer of high-pressure laminates. It's an Austrian company. So he's going to be talking about their structural sun shading systems. And then our last presenter for the day is Ranojoy Dutta. He is the Director of Energy and Sustainability at View. View is a disruptor based out of the Silicon Valley in the United States. So they are the manufacturer of electrochromic glass, which you can use to have dynamic glazing. So these are our presenters for today. I will move on straight to the first presenter, which is architect C.N. Raghavendran. I will just give him the control. Just a second. So he will be presenting first. So have you got the control? I've just given you the control. Right.
Got it?
Yeah, perfect.
Okay. Good afternoon, friends. Welcome to this webinar on daylighting and shading. I'm sure you're all doing all the right things to stay safe and healthy. And I hope we'll come out of it very soon. That's across the globe, not just to India, though. And we will surely be facing immense transition problems when we get back to work. But this period of lesser activity and lesser travel and confinement has taught us a few things about resilience, which I think will surely help us in our respective professions and work for the future. So I think we have to take the positives out of this bad patch. And one positive thing I can straight away think of is to appreciate ZAC Group. They've done a tremendous job of bringing in experts and speakers and spreading their net across the country and the various parts of the globe with a series of webinars and on very topical and issues on which everyone wants to learn more. And I really hats off to Mr. Zach and Ahad. And also thank you for good words, Ahad. I appreciate this. So I'm really amazed at your increased zeal and drive in bringing diverse subjects, and it's truly commendable. Now, one second. Okay. See, when you this is going to be a broad overview of daylight harvesting and shading. Now, I know officially it's glare, and glare. One of the ways of solving glare is shading. But I don't want an impression to be created that daylighting is bad, therefore we have to shade. So I would also like to talk side by side on the good aspects of daylight. And of course, the disadvantages and the problems that either too much or too little of glare, like daylight, impinges on us. Now, when you think of light, just like I spoke about Louis Kahn, now I can't but remember what Corbusier, a pioneer of modern architecture, was left an indelible mark on the global architectural world. He's one of the greatest architects ever. What he said about the light, and I would read this, but you have time to read this quote, and you can see very clearly how light established a connection with architects and the webcam seems to be closed. Hello?
No problem. It's because of the bandwidth. It's okay. We can present without the webcam because we're having slow speed.
Okay. So this is what broadly is the subject. As I mentioned, light, what relation light has with architecture was already explicitly said by both Louis Kahn and Corbusier, both great architects admired around the world. And now I'm going to briefly touch upon the relation that daylight has on life itself and the environment. Now, we all know it's very clear. You don't need no brainer to say that no light, there's no nourishment, there's no life, there's no human, animal, plant life. water cycle, nitrogen cycle, photosynthesis, and all these things, life supports get knocked out. But what is the option? What is comfort? Now I want to relate comfort to the light coming to us. The comfort, I have this not moving across.
No problem. Just click on that PPT button at the bottom.
Yeah,
Just
okay.
that one. I think it's.
1 second.
Yeah, I think it should move now, sir. Just try to shift next and see. Should work now.
This is like stuck. Sorry, folks. Yeah.
Okay, no problem. Yeah. Okay. Cool.
Okay. Now, see, when we explore light in relation to humans, actually, humans' physiology has set some targets for all human endeavor, particularly the way we live in and out of buildings. And since most of the time, almost 90% somebody calculated of the time that we spend indoors, and it's all the more important that the indoor conditions are comfortable and safe and healthy for occupants. And it should promote activity, it should promote wellness broadly. Wellness is a very large definition, and therefore wellness is important. For instance, this is just a question that came to my mind when we were talking about it. See, what kind of place are you all in, each one of you? Are you comfortable? Do you ever think of lighting as an issue? Does the source of light bother you? The thermal and physiological and visual comfort levels, does it ever occur to you, or does it ever feel important to you? But knowingly, unknowingly, and consciously, unconsciously, these are important not only to architects, it's all important to all the stakeholders. Therefore, I want to just briefly go out of the topic and look at what the architects and the built and those who are involved, stakeholders in the built environment, what are the challenges and what are their commitments? The role of an architect has changed dramatically. Gone are the days of these large master architects who think form is what he decides and function is what the client wants, or sometimes what the master says he has to live accordingly. But today, it's revolved to include what man contributes to the building, and through his building and the way of life, architects, the builder, the material suppliers, all of them, in what way they also relate to the environment, the products, the resources, water, for instance, and pollution of air and waste. See, all these issues are involved in the building. So an architect cannot but be engaged to have a synergy with all these environmental aspects, which we broadly termed as a green building. So green building has moved tremendous leaps. Now people are talking not of green building anymore, they're talking of a net zero building. And they're also talking of going beyond the net zero, which is a energy positive or a water positive building. Now, this is a summary of the shift in the approach to architecture. That is shift from form and function to human-centric, eco-centric, and human wellness and human comfort. Now, therefore, this brings a responsibility to all of us, architects and all the building professionals, to do what is right and to do what is right for the individual, right for the community, and right to the environment. And welfare of all is the eventual goal. And we know this because we have immense amount of building activity in progress across the country and across the globe. No doubt, slowed by certain economic considerations and more importantly, the current crisis. But eventually, the building consumes more resources. Building consumes or produces more pollutants and waste, and it's a net minus industry. And how do we convert it to positive? Industry is what our challenge is. But as I said, center of all is a human comfort. Now, therefore, coming to human comfort, how did different era, how did it look at life? Now, this slide is to just tell you what a caveman would have found. Now, he found that he needed security, he needed shelter from the events, but he cannot forego air and health. That's why the crude cave dwelling actually set a trend that even today is valid. It gives them shelter, it gives them protection from elements, and it gives them a level of wellness, a level of comfort, protection. I mean, his main concern was not to be eaten up by a lion. Therefore, this kind of what it started like this, and eventually moved on to the Iranian and Middle Eastern neighborhoods or cluster of houses, where the climate dictated.
Hello, Ahad. Did we lose?
I'm just checking.
Okay. Yeah.
So we have lost your voice.
Maybe he hit mute by accident. Sir, you might be
Yes.
muted.
Can you just check, sir, if you've muted your? I'll just call him. Hold on.
Yes. Okay.
Just calling him. Just calling him. Hold on. So we had lost your voice. Is it okay? Is there any issue? So can you hear me? So can you hear me? Hello? Oh, okay. Right. No problem. We'll do the other presentations and we'll come back. Right. Correct. Right. Sorry, there's a small power outage at Mr. Raghavendran's place. So there is his generator will come on in 5 minutes. So what we will do is we'll take Balaji's presentation. Balaji, are you ready? We'll take your presentation and then we'll have Raghavendran sir once his power is come back. Are you ready, Balaji?
I'm ready.
Right. I've given you the control. Sorry about this. He's had a power outage at his place. So we'll have him back after Balaji's presentation. Balaji, go ahead.
Can you see my screen, Ad?
Yes. And you can switch off your video, Balaji.
Yeah, I've switched it off.
Right.
Is my voice audible? Am I clear?
Perfect. Please go ahead.
Okay. So good afternoon, all. First of all, my sincere appreciation to Ahad, Amit, and the entire WFM and ZAC team because they are redefining the mode of what we used to call seminars into webinars, and keeping our knowledge enriched with all the learnings which we had been going through this particular amount of time. It's my privilege to share this virtual webinar space with Mr. CNR himself. He is the master of this particular topic, where I had also got an opportunity to speak about. And my gratitude to the other speakers as well. So without much delay, I'll get into the topic. So in my topic, I'll try to cover a little bit into deep with respect to what the sun shading systems are, and how high pressure laminate can make itself as a good product into usage of the sun shading system. So before I could start, yeah. So first and foremost, it's good to know what a sun shading system really is. So when you talk about a good sun shading device or a system, it's either mechanical, or it's textile, or it's made up of natural material. It can be a horizontal or it can be a vertical enclosure, which is done either on the interior of the building or the exterior of the building, or in between two spaces, which is interior and exterior. The prima facie of this particular element is to optimize the light and optimize the heat which gets into the building, thereby keeping the building cool in summer and then warm in winter, because the sun angles changes. Being India in a northern hemisphere, the or at the tip of the northern hemisphere, I'll put it this way, the sun angles are a little bit harsher. The summer sun is at a higher altitude and the winter sun is much more at a lower altitude. So the sun shading system should be capable of taking care of all these parameters and optimizing the heat. Why is it so important when you come to a country like India? As I'll only take it to this context. India is not only a country which stands united in diversity, but also in terms of various climatic changes which it has within its topography. As per the National Building Code, or even by Indian Green Building Council, the entire Indian topography has been split into 5 different zones. Majority, or more 75% of it, falls under either hot or dry, warm or humid, or composite climatic zones, where the effect of radiation through sun is much more higher, which means that the radiations in terms of light and energy from the natural source is for more than 8 or 9 months in a country like India in these climatic zones. So this makes it clear that you need a proper shading element in a country like India, where the light and heat is much more in abundance. Then comes the energy aspect, where I had to take some cue from the Indian Green Building Council themselves. When you talk about building as such, or a commercial building as such, I should also put forth the view that it's not the roads or highways, or it's not the industries or factories which are consuming more energy now. It's the commercial buildings. So when you talk about the split of usage of electricity within a commercial building, your air conditioning or HVAC plays a vital role, where almost around 57% is being absorbed by the HVAC systems. Almost around 22% has been absorbed in daylighting, or the artificial lighting. So these two factors makes it feel that yes, we need a proper shading element in for our buildings, which is really vital. And when it comes to the heat gains through various elements in the form of in the building forms, wall conduction and the glazing conduction plays a very vital role, or even your internal gains in terms of light. The number of people taking that particular space also adds up to the internal heat gains. So these are becoming very much vital when it comes to why we require a shading element which is really efficient. So when it comes to the shading, there are 2 ways to shade. Without doubt, there is a natural way to shade the building, and there is an artificial way to shade the building as well. So when it comes to the natural way, trees are the best absorbers, where it mitigates the heat island effect and keeps the microclimate to a reduced level. But the problem what we have is the urbanization, which gives us a very big challenge. What people or the experts say is by 2050, almost around 65 to 70% will be living in cities. So this starts to define the usage of the artificial shading elements. So I'll pause my presentation here a bit before I move into the next part of the presentation. I request Ahad to post the poll.
Balaji, I'll get the poll on in 5 minutes. Okay, I'm just having an issue here. Just get the poll on in 5 minutes. Just continue with your.
Okay. No problem. So I'll continue with my presentation. So now, when we have this challenge in mind, what do we really do? So we look at solutions. We look at possible solutions on how we can curb this problem, which we have it in hand. So when we look at solutions, the history of architecture itself gives us a proper solution, because India is a country where you have different forms of architecture clubbed in different spaces. You call it Chettinad architecture, where you have large courtyard openings being given, which acts as light source into the building, and even the cross ventilation itself takes care of the entire ventilation required for that particular structure. You talk about a Keralite architecture, you immediately the thing which comes into the mind are the roofs, where the stack roof effect comes into the play, where the ventilation happens through the stack roofs. So similarly, for even the walls, we have our history giving us answers. You talk about a Keralite architecture, wooden louvers are much more predominant, where you see the louvers which are slatted at a different angle, so that it optimizes the heat and light into the building. You look at a Rajasthani architecture, or you go a little bit northwestern, you call things called jalis or perforated screens, which are widely used, which again does the same thing of optimizing the light and heat into the building. So these two forms comes really effective, and these are methodologies which form under the passive architectural structure. So then it came into the mind, yes, now we have a pandemic situation in hand, where the ASHRAE and ISHRAE standards might undergo changes with respect to HVAC systems, because the occupancy ranges will change. The amount of filtering which is required in recirculation of air could become very less, because when you talk about any good HVAC systems, there is a good amount of recirculated air which gets into the system, which makes it much more efficient, rather than using more fresh air into it. But now we are in a situation where we foresee that these things might change. We might require a lot of fresh air from outside, rather than using the recirculated air. So
Balaji, sorry to interrupt you. If you want,
when I thought about, yeah,
if you want, we can take the poll now. So it's ready.
We can.
Yep.
We can add.
Shall we take the poll now?
Yep. Yes.
Okay. So we'll take the poll for a minute. So just if you want to read that out, you can just read it, Balaji.
Okay. I couldn't see the poll screen.
Fair enough. I'll just read it out. Is it possible to design a building without major usage of active cooling systems in India, considering the climatic challenges? So we've got 30 more seconds. I'm just repeating the poll. Is it possible to design a building without major usage of active cooling systems in India, considering the climatic challenges? We've got 15 more seconds. Right, I'm ending the poll. Right, so Balaji, the results are 40% have said yes, 34% have said no, and 26% have said maybe.
Okay.
Right.
So to continue with this presentation on what we had spoken about with reference to how the HVAC requirements would change after this pandemic situation, how fresh air would be much more required, and then the energy efficiency standards could change. I could relate it immediately to one of the buildings in India. This is a educational institution which was done in the heart of Jaipur. It was in between an industry. It was done in between an industry hub, for that matter. But the uniqueness of this particular project is this does not have any active cooling systems at all in this particular project. And how did they do it is what they could learn from the history of Rajasthani architecture itself. When it comes to this particular project designed by one of the leading architects, Morphogenesis, it combines modern architectural methodology with typical Rajasthani architecture. I'll also tell you how they did it. It has been designed to keep the temperature down without any artificial cooling systems, which is also possible in spaces. So when we talk about how did they do it, they combine two passive architectural methodologies to the best of its use. The one is the Baoli methodology, and the other one is the Jali architecture. Even during Mr. Raghavendran sir's presentation, he showed about some of the Jali images which can be used. So what they did, when you talk about Bali is nothing but a evaporative cooling methodology. It's nothing but you have a well or a pond, and then you have steps where the walls are constructed with heat absorbing material, where it absorbs the heat and then evaporates the water, thereby keeping the entire space cooler. And the second one is directly related to the sun shading methodology, which is the perforated or the lattice screens. Here in this project, this does three important elements. It filters air, number one, which is really required. Number two, it filters light so that it optimizes the light which is required into the building. And number three, it gives privacy. So these two elements combine to form a methodology where active systems were not even necessary, or it was completely curved off. And when you see the output of this building remains 20 degrees cooler compared to the exterior environment. Let's say if the exterior is somewhere around 47 degrees, which is an ambient or a high temperature when it comes to a city like Jaipur, the interior remains at anywhere between 26 to 27 degrees Celsius. So it is still possible. People are experimenting with various passive architectural methodologies on how to make the building cooler even without an active system itself, because that's one of the biggest contributor when it comes to the energy consumption in a building. So taking the cue from there, so what are the different types of sun shading elements which are used or which we commonly use? We use either a perforated screen, which is either made of metals, which is either made of aluminums, or which is either made of HPLs. We use textile fabrics. That is also one widely used methodology when it comes to sun shading. We use double skin, which is predominant, where there is two layers of glazing skin, one an internal skin and the other an external skin, but there is a small gap between the internal and the external skin, which acts as a ventilator. Again, we use louvers. Louvers are the most common things because it directly relates to our history, on the architectural history what we have. And the new concept which had come off late is the vertical gardening, where we even do facade gardening in some places, but it becomes a little bit challenging, where you need to maintain on various elements. So when it comes to the next thing, when how to select a good sun shading element, the first and foremost is the orientation of the facade. As I mentioned, India being in the tip of the northern hemisphere, when it comes to the global scenario, the orientation of the building plays a very vital role. So when if at all, if I'll have to say which orientations will have more effect with respect to the sun's radiation, as per the bookish thing, it would be more with respect to east, south, and west. North is anyway left over, but this will also have its adverse effects in some of the southern based cities. Until and unless you do a proper sun shading analysis for that particular building, we might end up eliminating some portion of north where the sun would be harsher even. So it is better to do a proper sun path and the shading analysis. There are softwares available for it to do the sun path and shading analysis. And the third important one is the daylight analysis. So these are the three things which are really required to select a proper shading system. And when it comes to the material choices, the slat thickness plays an important role, whether the thickness is larger or whether the thickness is lesser. The slat width plays a role. The center to center distance plays a role in terms of how much light or heat it is going to get into the building. The angle of inclination of the slats, again, because in different orientation, the angle of inclination could be different. And the most important one is the slab material itself. So what kind of material is it? Whether it is going to be a material which is going to conduct or too much amount of heat and then transfer the heat again into the facade again, which will become again a challenge, because when it comes to a primary responsibility of a shading element, it should cut out heat and then it should let in light, optimal amount of light. If the element itself starts conducting too much amount of heat and then absorbs and then mitigates the heat inside, then I think then it takes a little bit of toll. So now comes the thing on how high pressure laminates can be a material choice. As I mentioned, yes, high pressure laminates can be a good material choice in this particular segment, because the thermal conductivity of the material is much more lesser compared to any other conventional material which are being used in the form of the louvers or the lattice screens. The maintenance is very much lower because I think the global scenario, the high pressure laminates comes with an anti-gravity surface, so it doesn't allow the dust or any kind of dust to settle on the panel itself. It is highly sustainable. Some of the manufacturers, for example FunderMax itself, there is a certificate which says that this material is sustainable for 33 years without any change in terms of physical or the aesthetical appearance. So that is highly sustainable. It is flame retardant, so it adds to the fire properties as well. It gives a high degree of design freedom for any designer. The choices of colors and the surface finishes are multiple. It can be a matte finish, it can be a glossy finish, it can be even a textured finish in some of the colors. It can be wooden, it can be plain. So coming to some of the projects where they have used high pressure laminates as an material choice and come out with stunning performances when it comes to the shading system. This is a recent project which was executed a year ago. The beauty of this particular project is this involved a movable sun shading system. It's not automatic, but still it's a manually movable sun shading system where it can move 180 degrees, so either ways. It's an educational institution in Ahmedabad where in all the 4 phases it was used. It was not used in places where the windows were completely recessed inside, because the walls around the windows itself played as a shading element. It was used in places where the windows were a little bit recessed outside and it was required. So I'll go through some of the pictures. This is how when it partially opens. So this is a picture where some panels are opened and some panels are closed, which is possible. This is a picture where the same space is completely closed. This is a picture where the same place is completely open. So it adds up to both the beauties. It adds up to the functional element as well, and it adds up to the aesthetical appearance which is required for the building as well. When it comes to some of the other projects, this is a project which we executed, which was executed in Kerala, down the entire coastline with some of the harshest colors or some of the bold colors, I would rather put it this way. Again, a project in Kerala. This is a project which was designed and executed in Bangalore. It was designed by architect Dinesh Verma, who gave his presentation some time back. Again, an angled louver system. A horizontal louver system which was executed in a project in Karnataka. This was a library building for the educational institution where they wanted to take out much of heat and light. A government project designed by CRN Architects where we did a vertical shading system. It was a fin methodology where it was suspended at top and bottom. Jalis. Now coming to the concept of jalis, this was a international school designed by an US architect, where they posed a challenge in terms of designing a different kind of a jali and then fixing it as a secondary skin. So this was executed again with high pressure laminate panels again a year back, where the jalis are perforated to give the to optimize the light and heat into the glazing. Again a perforated HPL panel. Some of the international projects where they could combine well with horizontal and vertical applications. A different form of vertical louver itself, perforated vertical fins, horizontal fins, and then some of openable and then movable louver systems. Now coming to a case study. So we thought now we were clear that yes, HPL is one of a good material. HPL is one of a sustainable material when it comes to this particular element. We did a small case study to understand how it will impact in terms of the capex, the opex, the discomfort hours, what the ASHRAE standards be. So we took a small model. The city which was selected is Mumbai, because it's one of the harshest climatic cities. The climatic condition is warm and humid as per the Indian Green Building Council. The floor palette what we took was a 10,000 square feet floor palette, a simple 10,000 square feet floor palette, which had a window to wall ratio of 60%. It had window on all the faces. That's how we took the standard base case as. The base case what we considered was a clear glass DGU. We still went on with the DGU so that it will be still better. So when it comes to the benefits, now we need to make it tangible in terms of certain values. So when it comes to the benefit of a proper sun shading element, the first and foremost is the daylighting aspect. So how a proper shading system or a louver system can mitigate glare is something what we looked at. So when we started working, if you talk about a computer screen, it gives 200 lux. That's the amount of light which comes out from a computer screen. But when you talk about what is available nearby the window region, I think we have some disturbance.
Yes, I've sorted that out.
Okay. So in majority of the places, even at your homes, if you think about using an system, we normally sit nearby a window. So there is a large amount of light coming from the window, and if you'll have to measure it, it will be anywhere in the range of 1 lakh to 1,10,000 lux. This is the amount of light which comes, and whenever you look at your screen, it creates a glare. So a normal comfortable situation needs a glare contrast ratio of almost around 10:1, which means that if your computer screen is at 200 lux, the amount of light which is coming inside cannot be more than 2000 lux. So that gives the ratio of 10. So if at all we'll have to optimize it, even with the best of the best glass. At times you might need to have a proper shading element where it will also optimize the amount of light coming into the building. It can be optimized as much to a level of 1000 lux, which is still possible through a proper shading element design, which also mitigates the glare. And number 2 comes the usable daylight index. See, normally when you talk about any commercial space, this is something which is really looked at. How much amount of that floor space can be used without any how much amount of floor space can be used without any issue. So when you talk about the base case situation where we talked about a double glazed clear glass, if you talk about the UDI is only up to 70.4. But when you simulate the same with the help of louvers or with the help of a proper shading element, high pressure laminate shading element, the UDI, the usable daylight index, crosses almost around 85%, which means that you might not require a lot of artificial lighting, which is required for the floor palette to get into a proper workable condition. You can still conserve a lot in terms of the artificial lighting, and then use a lot of daylighting into your buildings. Then comes the biggest benefit in terms of the HVAC. We have considered this case considering only shading element or the shading device as the only contributor for energy conservation into the building. So when it comes to the thermal comfort, there are by properly devising a shading system using the softwares and using the sun path analysis, it is quite evident that we can curb out almost around 40% of direct heat gain, which is going to get into the building, and then add up to the HVAC load which are really required. So when we do a small analysis to understand what is the impact in terms of capex and the opex, because when you talk about HVAC, it has both the elements. It has the capital expenditure and it has the operational expenditure even. So for the same flow palette, when you talk about a base case scenario without louver, just a DGU clear glass, or with even without a louver, with a good high pressure, good high performance glass, and a combination of a louver with your clear glass DGU, the louver with clear glass DGU still performs much more better. Like if you could see through the graph, the base case which was without louver needs almost around or gives almost around 96,673 watts into the building. But when you talk about the base case with a louver attached to it, an horizontal louver attached to it, the load drops to almost around 68,000, which is nearly around 28,000 watts, which you directly curb out from the building when you effectively design louver. And when you translate it in terms of tonnage reduction, this gives almost around a tonnage reduction between anywhere between 7.5 to 8. And when you translate it into the monetary benefit, normally the tonnage, the commercial tonnage is almost anywhere between 24 to 25,000 rupees. That's the base case. So a 10,000 square feet space can save almost around 2 lakh rupees in terms of saving in a capex when we properly design a shading system. Now we need to also think, like, if at all, if 10,000 square feet itself gives us this good earning, we do lots and lots of we do millions and millions of square feet spaces in terms of commercial building. How much saving it can give when we properly design a shading element along with the glazing unit as such. Number two comes the OPEX, which is the operational expenses. Again, the base case uses around 65,000 units when it comes to the HVAC usage alone. But when it comes to the base case with a HPL louver system, it drops to almost around 52,000 units. So there is a direct reduction of almost around 12 to 13,000 units. And if you consider a place like Mumbai, where the commercial electricity is charged at 7.5 rupees, there is a saving of approx 1 lakh rupees in this 10,000 square feet space. So again, when you think about a larger commercial space, the savings are much more larger when we devise a proper shading system. Then comes the discomfort hours, because this also directly relates to the ASHRAE standards. What they do is they have a threshold temperature, and they calculate the number of hours where the temperature rises above the threshold temperature, and it's been calculated in the form of discomfort hours, because it directly gets related to the productivity of that particular space. So when you consider a case without a louver, with just the base case, the productivity hours are anywhere between 2,700 to 3,000 hours. But when you compare it to the glass, the same glass with a high pressure laminate louver system, then it drops to almost around 2,000 hours. So it increases the productivity by almost around 820 hours. So this directly leads to the improved productivity aspect as well. So to summarize, when you talk about the benefits of designing a proper shading system with high pressure laminates, either it could be in the form of a slatted louvers, or it could be in the form of a lattice screen. It gives its benefit in the form of daylighting, where the daylighting is much more optimized. The thermal comfort is much more optimized, where we saw it in the form of the capex and the opex gains, what it's been got in terms of monetary value. It also adds to the green benefits, because the entire construction or the material itself is FSC certified. So it adds to the green construction even. And when The passive architectural methodology is also used. That also adds to the point when it comes to the Indian Green Building Council. Just to summarize, yes, it's a complete green building system where it addresses through the needs which are really required in terms of energy conservation. The carbon emissions are really going down, where the buildings are the major contributor as of now when it comes to the energy consumption. We can really conserve it by properly using these systems. The water is being saved in a very lot way because the slat which is made of high pressure laminate itself is less in terms of maintenance because of the anti-gravity surface. So you don't have to maintain it frequently. You don't have to lose water in terms of maintenance. It addresses all the three pillars when it comes to the sustainability. It addresses the environmental factor where the microclimate is being taken care of. It addresses the economic factor where the energy conservation is much more larger when you optimally devise a shading system, and even to the social factors. The productivity has been increased when we design a proper shading system, because we saw it in the form of discomfort hours, where there is a drop in terms of discomfort hours as per the ASHRAE standards. So just to finish my presentation, I can only relate it to Mr. Frank Lloyd Wright, because this is the famous architect who designed falling water, where he took the entire water into the house and then brought it outside, thereby keeping the entire thing cooler. Without an architecture of our own, we have no soul of our own civilization. I think we have a strong acumen when it comes to the architecture itself, because the Indian architecture are the much more spoken about. And I think with effectively using our passive architectural methodologies, we can still design a much more efficient spaces which can address the needs of pandemic and other things, and still work ourselves towards the UNDP sustainability goal, which is where we can add ourselves with reference to the sustainable cities and communities. So with this, I end my presentation.
Thanks, Balaji, for that interesting presentation. Lovely insights on different shading devices. Okay, we will now have Mr. Raghavendran back. I hope his net is there. Sir, are you there?
Yeah, I'm there.
Right. So I've just given the control back to you, sir. Yes, we can hear you loud and clear.
Okay.
Right. Okay. Please go ahead.
Now I'll start from where I left.
Right.
So I was talking of the two things. One is a cave dweller, and another is a Middle Eastern or a mid period harsh climate community. Now, a light also creates a lot of grandeur to a building. A Pantheon on the top right is one of the often quoted building where the power of light is brought into the building space, and the space becomes enhanced in terms of overwhelming the occupant in that place. So light can give different moods and shades, and it can move from across the spectrum, and that is indicative of this. And the last one, of course, Rajasthan example has been quoted often, but it's a kind of trellis in which they shade. Now, shading is also importantly should be unobstructed in terms of outside view. Now, outside view is as important as any. Therefore, this shading combines this, and this again is an indigenized solution, created centuries back, and is as valid as it was at that time. Currently also. Next slide.
You got to click in the center, or you have to click the PowerPoint.
That bottom thing is
at the bottom. Yes, your.
No, bottom. I don't see that arrow here. Something else. Some push one. Oh my God. I just escape and come back to.
No, you just click the, I think the bottom, if you click the PowerPoint on the right hand side, that, yeah, the PowerPoint left. No, you come to the PowerPoint, the P, the one, the red button at the bottom.
Yeah. Okay.
Red one, just next to that, yes. If you could just click that, I think. Right,
yeah,
now.
Yeah. Okay. Now, these are again examples of, sun getting shaded. Now, why I showed all this was that, these are all heritage buildings across the geography of India. Across geography of India, whether it's north or south, you find people came up with indigenous solutions to a problem which at that point of time, it was self-reliant, it was non-technology dependent, and it created, most importantly, it created a character of its own. So, these buildings became iconic, and these buildings are still remembered and, admired across the globe. So this how a natural challenge was converted into a great opportunity. Now, another feature is, I was talking about the light, the mood that light creates inside a building. Now, this is a famous work of a chapel by Corbusier, and again and again you go back, but see the different kinds of moods and the playful drama that's created in the space, open space. The kind of, this, how can anybody imagine that you can get such a streaks across the wall? And it's almost like such a dynamic and playful kind of situations. So this is all through careful control of facades, fenestrations, and angle at which the incident happens. Now that's across. Now in Indian example, I can just cite two things that I have found quite good. This is the first three. The four are the famous India Habitat Center at Delhi, designed by the Joseph Allenstein, who was a highly recognized architect. He worked in India, but recognized across globally. No matter whether you're inside an office or outside the office, within that courtyard, the courtyard is so well shaded, and the officers get ample light, and the shaded area is so popular. People come out and sit in that area. In fact, people come and sit outside, not only for social gatherings or anything, or even work is brought outside, and they can work from outside. Because today work, you don't need to be tied up to a single place. You can walk out and do it. And this building, continues to impress me, despite it being done about 30, 40 years back. It's a wonderful space created, and light creates this. Light creates this, and shade enhances it. This is the beauty of this place. Now, the one you see at the bottom right is a building we did for Tata Consulting Services in Chennai. It's a very large campus for IT services. It seats almost about 35 to 40,000 people. Now, when 40,000 people, we wanted to create a university kind of atmosphere, a street in which people can gather, mingle, and create useful discussions, interactions, and serendipity. So that was made as pleasant as possible by a mix of water, vegetation, hot pavements, and a central cover, which had sides open. The shade on top actually creates such a volume of air to come in and go out that the place here is automatically cooled. In fact, many people prefer to step out of the air conditioned office, but sit and enjoy this open space. So shade has got a tremendous character to it. Now, I just keep this because advantages of lighting is well known, and if we say a paucity of time, it also has been covered earlier, that light gives you a better environment to work inside, whether you work or living or whatever activity, human activity is made pleasant and healthy by means of light. Lack of light not only creates physical problems, but also creates psychological problems and physiological problems. Therefore, light is very important. Now, there is humongous amount of benefits coming out of light, and people found that a badly lit office space can actually create fatigue and also have a impact on the productivity of people and the wellness aspect of it. So this is again an example of how different people, different architects and different circumstances have creatively come up with solutions that take advantage very creatively of light to enhance the quality of the building inside. Now this again is a character. The reason for my bringing this up is the light and the eye, and the relation between light and eye, and also this radiation coming annually to a location. You can see the direction. Direction is important. North, south, east, west, and how the radiation goes up. It's not only the sun direction, but also the radiation, the impinging radiation on buildings play an important role. This is particularly important when you're designing a fully glass building, or at least a predominantly glass-oriented building. Now, between roof light and side light is easier to handle because it's already shaded most of the time, and except east and west, you have better chances of getting an even unglare lighting without much of glare. So this again creates a tremendous atmosphere for people to work inside. Now, how do you make the light travel inside? Now, light, after all, you have window and glazing of or whatever form you have. The impact of that lighting is only up to maximum 10 meters. So beyond that, the lighting level drops down. Now, the whole idea of lighting inside is, depending on daylighting inside, is that you reduce use of electric lighting and you save energy, and you contribute in a tremendous way. You save energy, but it has a chain reaction going all the way up to production. Therefore, this is environmentally an excellent strategy, but also in terms of initial cost, operation cost, etc., which was also previously mentioned. Now, to make that travel far inside, you have a system what is called daylight shelf. Now, daylight shelf, you see on the left, you see a window with no shade and light coming in through this. This light could be quite harsh if the sun direction is, it's in the wrong location. The window is in the wrong location. But by providing a light shelf, it not only provides the shade, but the light falling on that light shelf gets reflected and travels up to the ceiling, and again gets reflected, and then the light penetration, daylight penetration, increases from about 5 to 6 meters or 7 meters, almost up to about 10 to 12 meters. And this is a very practical possibility that has been used successfully both in India and abroad. There are different kinds of lures and light shelves, and also lures and blind systems. I will not go too much into this for paucity of time. But you also have panels which can, by the way the glass panel is made and the sunlight is refracted, the sunlight is coming at an angle should normally have come down and hit the ground. But because it gets reflected, it becomes almost horizontal. Therefore, it travels far into the innards of office spaces, and therefore you get a more even and pleasant lighting. You don't have dark spots. You don't have spots that people avoid because of being dark. You also same thing can be the glare, for instance. Excessive glare can be created by, can be taken care of by this fine laser cut panels, which already has been mentioned earlier. The other point of bringing light is through solar tubes, which actually capture daylight right on the roof through a prismatic kind of arrangement, and through a polished set of tubes, it brings in and can light spaces that are away from windows, or even spaces that have no windows at all, like basements. These tubes again work very satisfactorily, and even areas which have no windows, no external surfaces outside, it can be lit through this. For instance, you get almost working condition inside a factory, totally dependent on solar. This is in fact advanced system which we tried to incorporate in one of our projects for Infosys was a combination of this solar light panel which comes in. It's integrated with actual electric lighting, which has a sensor. So the sensor automatically brings in daylight in daytime, and the sensor recognizes a dip in daylighting lux levels. It automatically switches on the electric light. The idea is that one doesn't have to go out and switch on. It's not timed as per the same, but it is reactive to the external conditions. The overcast sky, cloudy sky. So these things transition automatically. So that's the idea of this kind of protection. We can see the daylight here. We can see this bright spots on the ceiling, which brings in light, and it also provides shade for the immediate adjacent area to the window on the external side. Now, the applications across residential institutions, industrial, and hospitals, and recreation and commercial, and also in a large scale projects like airports. For instance, the Chagi Airport has got a beautiful ceiling suspended vertical elements, partly vertical, partly inclined, and partly reflective. And that creates a wonderful internal atmosphere, which is almost uniform in lighting levels. And it's in spite of so much of direct radiation coming into the building, this kind of set of lower arrangement, this set of ceiling arrangements dissipate heat and allows ambient lighting to come in, make the interior very pleasant, and also create a very good ambience inside. And these are all, I'm suggesting all this to show that innovatively it's becoming more and more common that people turn what could be a disadvantage into a great advantage. And this is a building which we did in Chennai. It's an office building, and this is facing south, and the view outside the building at this location was quite good. Nobody wanted to lose that view across. Therefore, the glass was inclined, and we had an overhang, a deep overhang with louvers, and you could see the balconies also were extended. The office balconies were extended in such a way that you get well-protected, glazing, which allows you views across. This is the Infosys campus I mentioned a little earlier. The roof light which comes through, which also creates a stack effect, which also creates an effect of a chimney with the top hot air going up is blown across by openings across this place. Now, this is a library building that we did at Chennai. It's called Anna Secondary Library, where again the kind of internal louvers, internal shading prevented solar transmission inside, direct transmission inside. At the same time, provided less harsh conditions along the glazing. And important thing was that we wanted to depend as much as daylighting as possible in the library, in a particular application like library. Now, these are some industrial applications that charge switch across. Now, this is a diagram on the bottom right. I'll just very briefly touch upon it. This horizontal line is the desired level of illuminance inside. Now, the curved line represents the solar daylighting coming in. Therefore, the mix of these elements can create a balanced condition. The louvers, which are reactive to sun directional movement, can actually allow less light to come during this peak period and more light to flow in the mornings and the evenings, so that you get a maintain uniform condition and so on. Now, all this is done through simulation. There are several software available. It does the external conditions. It also checks the atrium concept. So now we have several buildings, particularly commercial and office buildings, with a huge atrium. And there are also residential apartments with a huge atrium. That's intended to bring in daylight and fresh air. Now, daylight, there's a program which you can actually check how far deep, supposing it's a 15-story building or a 24-story building, for the atrium to be effective, what is the effective size? And sometimes if you need, you have to step back one side of it to make the lighting levels even. And of course, for ventilation, it's possible, but it's a completely different set of software I will not touch upon. It's a CFD kind of thing, which senses. And smoke control also happens through CFD. Now this, again, skip all the various kinds of software, which you can check the illuminance level. In fact, Ecotech is a very versatile software, which helps not only not only it checks the lighting part of it, but also the overall indoor condition. I'll skip all this and go to certain examples I have, which is creative and adaptive, expressive trends in future. Now, this not necessarily in India, but it will be soon. Sorry, just. Now, I just look at some dynamic facades. Of course, there's going to be a subject on dynamic facade coming in later, and these are live examples of how dynamic facades work. They are just the light and temperature in the room by controlling. It's all by self-control, user control. The user can control and maintain the levels of lighting and levels of temperature to suit his position in the floor plate and manage the comfort levels. And then you have light control dynamic facade. Now the dynamic facade again, this is again a very famous building in Abu Dhabi, the Investment Council headquarters, which has a filigree kind of an effect. It's actually reflective of the culture of the heritage culture of some of the buildings that were existing in that desert country several centuries ago. So adaptively, the architect has created a facade which not only symbolizes or connects up with the tradition and heritage, but also creates a kind of dynamic facade which keeps the inside more efficient in terms of lighting and power, but also enhances the quality of life itself. Now, these are wind responsive dynamic facades. Now, here again, you have a dynamic pattern of motion, and this again being used in Brisbane domestic terminal car parking, where you have these small prisms, small plates hanging, very intricately designed, and it's a very simple mechanism, but it's mounted in such a manner that the wind can disturb the pattern, and the wind, it not only provides shade inside, but also creates externally a constantly dynamic facade depending on wind movements. I mean, imagine a building almost coming to life if there's a wind. This is a phenomenal example of how architecture can become, come fully with life. And there are different forms of geometries that are adopted to provide shade, to provide lighting, both vision and spanner panels, they're all taken care of, so that you not only create a very balanced and dynamic kind of a situation for the inside conditions, but also externally, the building presents itself as as an expression of the intent of the architect. You have, of course, vertical living gardens. This is, of course, becoming extremely popular. In fact, certain countries, for instance, Singapore has by mandate stipulated that these green facades and green, like a biophilic kind of design, that is bring nature close to place of living. And how do you do it in a tall building where you're completely cut off from nature? So that practice is also being followed. And it's going to be a trend which is liked by people who live in the building. This is again a very famous building, and the key feature is that it's a fabric. It's a rhomboidal textile fabric, which is mounted on a lightweight cable stay structure. And these have been so nicely designed that, again, to reflect the local heritage and culture, but also allow vision right across and shade the glass. In fact, the theory is that the glass, if you shade it, and there were times when the buildings were fully glazed. And in fact, in India also, we create a full glass building, and then we try to solve the problem of ingress of heat. And definitely, if India is a problem, it's in Saudi Arabia, it must be a bigger problem, despite that being able to afford the power cost and the capital cost and so on. But still, the attempt to become conscious of energy consumed and also to create an architectural character, these kind of design thoughts and design trends are catching up across. So you can see the textile fabric very clearly. It's a very ingenious kind of design, very simple to fabricate, very simple to erect, but it just made possible by a close collaboration between the architect and the engineer. Now, this again shows that it's a multi-dimensional approach, serves for the better quality of buildings. And there's another very interesting building in Chicago, which has got reflective solar arrays. The solar arrays are responsive to sun path, and based on sun path, they keep changing the direction, not only for generating power, but also for shading the insides, and also afford view outside. Because view outside has been recognized as a relief feature for people who live inside building. And if you don't have an external view within a specific distance, many of these rating systems, both Indian and abroad, they look down on it. Now, these are again movable detached kind of louvers, which has already been mentioned. I'll skip this across, and then we have media facades. Now, these media facades are interesting because in daytime it gives you shade, it gives you glare freeness, but whenever you need, you can actually convert it into media for use of media as a visible element, as a dynamic visible element. You can reflect many things that the owner of the building wants to project. Then you have material wise, you have different new technology and new materials have come across, like this polycarbonate sheet. But my personal view is that many of these materials need to be not copied simply because it is a success elsewhere. We need to really look at the Indian conditions for this. Now, this again fabric through a cable stay structure, and which is dynamic, which is related to the solar movement. So depending on the solar movement, the sails swing across. You get daylight, you are less glare and less heat. Now, these are through building elements itself. Building elements itself forms the shading and protection. Then you have all this biophilic design that I mentioned a little earlier of offices and housing and commercial buildings having a living garden within reach. What a relief it will be for a person who works in that building to be this thing. Now, looking at design goals and approach, this is again one of the subjects that how do architects approach this. This is a very fundamental basic diagram that you start with. And as I mentioned earlier, you try to avoid direct impingements of solar on your glass. Depending on the direction, you get a very efficient building in terms of this. Now, this chart that we made, again, it's for the Infosys building that we tried. We decided on a pattern of solar protection, both vertical and horizontal, and studied it for different conditions on the summer solstice day, which is the worst period here, for different directions, both in terms of the ability of the building inside, the glass to be protected from direct impinges, both in plan and section. It's a very mechanical and simple way of doing it, because you have a sophisticated computer system doing it. But it's to explain it to a project owner who wants to know from basics. This kind of studies help them to reach out. Now, this is a building that we did for Amazon at Hyderabad. It's a very large office space. Here again, the orientation, the massing, and the building was done in such a way that, as you can see in the left bottom corner, one part of the building shades the other part of the building. So that way your glass becomes more efficient, your power becomes more efficient. And through the system of the selection of shading also was tested both for daylight enhancement and also for preventing solar ingress. These were done for different situations, different floor plans, to see how much of impingence impacts the inside conditions. Then you have a program which studies this whole pattern to see how much of the lighting levels you can get on a daylight. So it varies from more than almost about 500 lux to 110 lux. So the shading device doesn't stop lighting completely, but it allows good enough quantity of light to come in and reduce the area which is more intense in terms of heat and so on. These are some of the pictures that we made at this stage. And there's another building that we did at Bangalore. This is for a government health services department building. Here again, extensive solar studies were made, and there's a huge courtyard inside, which brought light to both sides of the office. And I mentioned a little earlier about the study of light penetration through a vertical atrium that is also tested here to see how effective it was. This is the Infosys case that I mentioned. This is the building, how the study of sustainability solutions were physically tested through a computer program. And these are various software solutions which actually bring out graphically what we are trying to assess and what we feel is an advantage to us. So all this kind of software is all the more becoming very important, that an architect not only has a creativity in his mind, but will be able to use the technology tools to evaluate buildings that he's designing. It's no longer good enough to say that my building is very good, but you'll have to prove it and measure it. So this willingness to measure, be evaluated, not necessarily by an external agency, but by his own self. It's really an honest attempt on the part of an architect to do what is right. And there are motorized aluminum louvers, there are perforated skins, and there are ceramic louvers. As you can see on the right side, it's actually the office of New York Times in New York, and it's got a ceramic system of louvers which creates a fine balance between cutting off heat but allow vision and also allow daylight to penetrate. And these are again building elements, like concrete itself can become an extruded or perforated, and also Korean is another synthetic material, resin based, which also can be used because it maintains itself. Then there are range screens, terracotta range screens, and so on. Now, I just want to touch upon some of the new technologies and innovations that are happening in this field, particularly in the area of glass technology. You have the chromatic glass. The chromatic glass is a glass in which, through an electrical stimulation, you can control the light transmission through the glass, and you can do it very selectively also. If you see the picture, the full glass is allowing light to come in. Then at a flick of a switch, the current passes through the part of the glass. Then you get that glass having a lesser light transmission. So you have, lesser light transmission. So by combination, anything is possible. And you can create where you want, higher daylight and where you don't. Now this is again a study of another new product which is being tested currently, and of course it's also been used. It's a panelite material. It's got a internal honeycombing panel, which allows high degree of light transmission, but at the same time outperforms even the chromatic glass in terms of shading coefficient and in terms of the solar control light transmission. So these are all new directions and the materials that I think, if not this generation, the next generation architects can follow. This exactly shows how the reflective solar heat reduces energy consumption, but at the same time distributes light evenly and works very efficiently. So for instance, at a very low solar value, you can see the chart below, high performance IGU has got a shading coefficient of 0.27 and vertical light transmission of 64. In this panelite, it drops down to 0.09 and 23. Now, these are phenomenally good technical figures for these things. And panelites can be used in many different ways altogether. And it's been used also. This again is a graphical representation of the performance of visible light transmission and also the solar copper coefficient, SHGC. And lastly, this is the new product, which is a metallic product, which can be molded and taken across completely. So this is, I'll just skip this again. And there are regulations, both ECDC and National Building Code today specifies the insulation value of an exterior, not only for vision panels, but also for opaque panels. Even plain walls need to be insulated. And therefore, the whole idea is that insulate a building. It's a one-time cost, but the recurring saving that you get out of this insulation is phenomenal. Now we've done a study in which doing nothing gives you a certain value, the top row, and doing reasonably everything drops it down to 0.62 units. This is a tremendous drop, and how this can be achieved by passive design of buildings, is a permanent example. So I think I'll come to the end of my presentation. It was a very deep topic. I didn't try to do very highly technical stuff, but I wanted to explore and see around, and make people look at what is possible. Thank you very much.
Thank you, sir. Thank you so much for that insightful presentation. I think it was in depth from different materials to softwares to future technologies. So just staying on that same trend of future technologies, one of the technologies you presented briefly was electrochromic glass. So we are taking that forward. Ranojoy Dutta, who, from View, will be now presenting on the technology in depth and how electrochromic glass is not a material of the future, but it is currently the material of the hour. So Ranojoy, over to you.
What do you see right now, Ahad? Do you see my screen, my full screen slide?
Right. Yeah, could you just change your display settings to slideshow mode?
Yeah, it's in slideshow. Okay, hold on one second.
Your display settings.
I think I am in. Oh, you're seeing my. Okay, hold on one second. Yeah, hold on one second. Let me just change it to.
Right.
Presenter. I am. Oh, got it. Okay, one second. Okay, now I think it will work fine. Just let me know.
Right.
Do you see my full screen? Okay, perfect. Yes, okay, thank you, Ahad, and good afternoon, rather good evening, I guess, for most of the people. Thank you for your patience. I hope you can spare another 15-20 minutes. I know we've gone over time, but I think it has been well worth it. Both of my, both CNR sir and Mr. Balaji have great presentations. In fact, CNR sir touched on a couple of things which are going to be key in my presentation in terms of both health and wellness and sort of this electrochromic facade. So without taking any more time, I'll get started. I'll try to keep it within 15-20 max minutes. I'll do the best I can. So I'm going to talk about what I think is the sort of the next generation in facade technology when it comes to both allowing the architect to really utilize glass to its fullest extent, which currently the technology doesn't allow. And also the focus is about the occupant experience, because quite frankly, once the building is done from an architect's point of view, it's really the occupants who have to live with the design, right? I mean, for most of us architects, we don't live in those buildings. So we really have to understand how are occupants experiencing the space. So my agenda today is I want to kind of start with basically revisiting why do people design with glass, and both the other panelists have touched on this a little bit. I'll kind of keep it brief. Then I want to get into the introduction to what is this dynamic glass, specifically what is View Smart Glass, which is the product that I'm representing. And then, I want to get into a couple of actual comfort case studies where I will show you measured data on both glare and thermal comfort, because in my mind, both are important to solve. We can't really solve one and not look at the other. Both comes within occupant comfort. And finally, time permitting and how things go, we'll look at some some project profiles of actual buildings. So let me get started. So the basic fundamental question that we all kind of want to start with, or rather I want to start the presentation with, is why is a glazed facade desirable, or why do architects want to design with glass? Why do owners and occupants want glass? So there are several attributes, right? But there is aesthetics, there is that ease of construction, there is access to natural light, there is the connection to the outdoor views. Now aesthetics is kind of subjective, I don't want to get into that, but because this is a technical conference. But the other two, when it comes to natural light and outdoor views, I think Sienna Rao sir has already talked about it. There is irrefutable growing body of research that these two, access to light and outdoor views, have a very, very strong connection to health and wellness, whether it being regulating our circadian rhythm, whether it's improving the moods, productivity, eye strain, whatnot. So that is, without a doubt, there is enough evidence that we don't really need to even do any more research on that, in terms of trying to convince people that natural light and outdoors views are important. So everybody understands that, most architects kind of intuitively understand that. But the challenge is that with traditional glass, and when I say traditional, I mean the standard products, even so-called high performance products in the market, if you don't have a shading solution, right? If you don't have a way of shading the standard product, you're going to end up with something like this, right? Which is, all too often you're going to see significant glare problems. And if you don't have glare, you might think, okay, I'll turn around, I'll face the other way, not face the window. Then you'll end up with a situation where you'll have thermal discomfort, because thermal is even less forgiving, right? With glare, you might turn your computer around, you might look at some other direction, you might get away with it. But as long as you are in the sun, as far as thermal is concerned, you're going to have a pretty bad experience. And you can see that an infrared camera will capture that kind of surface temperature differences. And I'll give some examples of this down the line. So what happens is that if when, despite all the good intentions of the architect and the requirements from the owner, all this glass is getting added to these buildings, right? And this is the outcome of the lack of solar control through glass, essentially, right? So you can see this is, neither is this aesthetically desirable, right? You don't have outdoor views, there is reduced daylight. So essentially, what's the point of even having all these glass windows? So clearly it is important to question the status quo of designing with glass. I think the time has come, and what we need is not an incremental solution. It has to be a transformative solution. It has to be a disruptive solution, almost, so to say, right? Because this is a glass, hundreds of years it's being used. So it's time to really look at something that is completely different. The key point to understand is everything around a building is dynamic, right? The weather is changing on a day-to-day basis, hourly basis, even on a minute basis. So how is it that a static facade is going to keep up with something that is constantly dynamic, right? Something to think about. So that's a fundamental question to think about. So if these constraints are taken away, right? If you can design with glass, but you don't have that discomfort, thermal or visual, what can spaces look like? So I'm going to show you some examples of actual installs of View Smart Glass, and you can see what the space looks like. So this is an example of an office, right? This is how the space is getting transformed. The architect is able to realize their vision. This is an office example. This is a hospital. You can see the quality of light and connection to outdoor views. Be it an airport, this is another example, right, where you can see the kind of expanse of glass that you have, absolutely no shading. And then finally, this is one example of this is a university building. I believe is some kind of a common area. I think it's in Georgia. So the point I'm trying to make is that architects are using glass for a long time. It is part of their design palette, right? It is nothing new there. But the challenge has been, how do you design it and keep that intent and not have the building completely covered up by all these kind of internal shades, whatnot, where the people are actually not able to get the benefit of the glass, right? Or the other extreme is, they want to take advantage, but it's so much uncomfortable that they have to walk away. They can't even sit there, right? And then you end up with all kinds of expensive, costly solutions to cover it up and this, that. So that's kind of my premise of why we need to think differently. We need to look at some new ideas now. So with that, I want to get into this concept of smart glass, view dynamic glass. So I want to talk a little bit about the company real quick. This is a US based company. We have almost close to 700 projects now. Almost about 500 projects have been completed. These are very, very large projects. I'll give you some examples, including entire airports, hospitals, multifamily housing. Obviously, commercial offices are sweet spot. So this is something that is growing right now. Our biggest market is obviously North America, US, Canada, but we are very, very actively looking at the international market, where India being basically the top of our list. And I'll show you a couple of examples of projects we have done, and there's several that we are kind of in the talks with, but they're just, this whole COVID thing came in the way, as you can imagine. So I want to talk a little bit about what is this dynamic glazing. So let me step back for a moment. So dynamic glazing is a bigger umbrella of products. Okay, electrochromic glazing is one of the products within that umbrella of dynamic glazing. So dynamic glazing, as opposed to traditional glazing. So traditional glazing is basically a product that has a fixed solar and visible transmission. So once you put that on your building, that's it. For the lifetime of the building, that is not never going to change. In fact, it might even degrade if something goes bad, but it will not change, right? Technically, it's not changing. Dynamic glazing is fundamentally a glass product where you have the ability to change the properties, the transmission properties of the glazing, the solar transmission, the visible transmission. So this can be done in different ways. There are products that can be done controlled passively, such as thermochromic or photochromic, and then there are systems that are actively tunable, which is electrochromic. The difference being active is where you can actually control when and how you want to change it, right? So that's a very key important point to understand. So for electrochromic, the mechanism is done through a electrochromic coating that is applied to the inside of the outer pane. That's what's shown here. So when a small electrical voltage is applied to that coating, there is a change in the optical property of the coating. So it goes down to the physics of that material. And based on how much voltage we are applying, the opacity can actually be controlled. So it is kind of tunable. And then when the voltage is reversed, it goes back to clear. So that's in a very high level what is electrochromic technology. So here is the we coming back to the View Smart Glass, which is electrochromic. So our product has 4 tint states out of the box. This is not 4 windows. This is one window for 4 tint states. The clearest state has a TVIS of 50%, SHGC of 0.38, right, and goes all the way down to 1% TVIS and 0.09 SHGC. So this range is almost impossible to find in any, especially the lower ranges, you are not going to find in a glass product, static glass product, that is, unless you want to be in a dark space all the time throughout the year, right? That's not how you would like to design. The beauty of this is that you have a range where the product can do different things at different times, right? Depending on the season, depending on the time of the day, and it's going to maximize the availability of daylight and or control glare and thermal discomfort. The point to note is there is never any obstruction of outdoor views. Even in the darkest tint state, you're able to clearly see through outside. So I want to make it very clear that there is no clouding in the glass, there is no haziness in the glass, none of that happens. It's always crystal clear, even in the darkest tint state. So this is sort of our product. This is the 4 default tint state. I will add that the tint states 2 and 3 can be changed a little bit based on customer preference, but usually our 1 and 4 are kind of fixed, the extremes. And we can do different combinations. You can have an additional low E if you want a better U value and whatnot. So that was the coatings part. Now, how is this window kind of installed, and how is it set up on site? So obviously this requires an electrical voltage. So there is a small hole that needs to be drilled in the frame after the glass is installed. And there is a wire called pigtail which goes and connects to what's called a window controller. This is about 4 inches by half an inch. This is what drives the voltage to the glass. And then finally that's connected to what's called a single trunk line, which is sort of goes into like a 2 feet by 2 feet control box, which can sit in your IT panel. So one box can control 256 windows. So the beauty of this system is we are not drawing individual wires from each window back to some 200 feet into some IT closet. This is a linear drop network where the individual windows are connected to a single trunk line. So that's the beauty of this network. Now, obviously, this network is carrying both data and power, and the opportunities in terms of IoT, Internet of Things applications, is tremendous. And unfortunately, I can't get into that because this is outside the theme of this presentation, but there's some significant product features that we are launching that are coming down the line, which I would love to take offline if anybody is interested. But that's the beauty of having this network in place already. So once it's done, depending on the construction of the building, it might not even be visible to anybody. People might not even know that this is some kind of special glass. It's just there. Unless it transitions, you wouldn't know. So we have worked with different glazing systems, 700 plus projects. So we can always find a solution in discussion with the architect and the glazier, whether it's butt glazing, whether it's a punch window, curtain wall, whatnot. So I covered the material science part of it, the networking part of it. Now, this is how is this glass being controlled, right? This is automated. I mentioned that. So we have a very sophisticated predictive control algorithm that is controlling how these tints, these 4 tint states, how are they being selected, right? We don't obviously want the occupant to have to keep sit and press the button. That defies the point of having an automated product. So there are several inputs that go into it, starting with the whole physical geometry. We build a 3D model of each building before the glass is commissioned. So we know what is the azimuth of each of the windows. We know what are the nearby obstructions, if there are other buildings, if there are reflections from other buildings, are there overhangs on this building, what's the size of the window, where are the furniture inside the building. All of it goes into a radiance model, and then we run for that specific climate. So we know beforehand where is the sun going to be, what time of the day, how much glare can there be, how much heat can there be, and what should the glass be doing. Now, of course, the reality is that on site, the weather will keep changing. We can't predict everything. So this is the predictive part. So what we also do is we install on each building, there are sky sensors which are installed on the roof, only on the roof. Just to be clear, we are not installing sensors by facade. There are no currently sensors per window, anything like that. Just one sensor array on the roof, which tracks the cloud movement and overall change in solar radiation. So this is what feeds the predictive system and lets it know that whether it's really dark enough for the bright enough for the glass to tint or not. So in a nutshell, these two in combination, in tandem, we have this predictive model which is kind of autopilot, and then we have the sky sensor which is tracking the weather, which is kind of like the pilot. So these two together are flying this sort of ship, so to say. And again, this is a very, very high level explanation of this technical program, but I'll tell you this much: we are looking at very sophisticated machine learning algorithms to improve the prediction of weather. It's a very difficult challenge, but we are already putting resources on figuring out what is the best way to control this class, because the aim is to always optimize for daylight. Whenever it doesn't need to be tinted, we don't want it to be tinted. We want it to be clear to allow for daylight. So that's in a nutshell the 3 parts of the product: the coating, the network, and the software. I want to now give you a demonstration of what this looks like in real life. This is a time-lapse video. I hope this internet speed will allow you to see this. Quickly, this is a very interesting site. This is actually New York. This is the famous iconic Chrysler building here. This is the east facade. This is the south. So what you see is the glass is already tinted right now. It's in the morning. So the east, as you can see, the sun penetration is very deep, right? So it's already in a tint state, but the south facade is clear because the sun hasn't reached. So let me play the video here real quick. So you can see that the upper vision daylight area has already cleared out because the sun has gone higher and sun is starting to go towards the south. So now you see the south has tinted, but the east facade has automatically cleared. So there's always a balance of light in the space because not all the facades are tinting at the same time. And again, this is I'll just play it once more. Again, this is a very, very customizable product. Depending on what the customer wants, where the furniture is, whatever their preferences are in terms of the tint state, whatnot, anything can be done. And the beauty is because it's a software control, we can do this completely remotely. We don't have to even send anybody over to these buildings to do this. It can be completely done remotely through the network, right? So that was a quick sort of vision of what the product looks like. So now I want to talk about some comfort case studies that we have done where we have compared our product with the traditional glass with the internal shades, because that's the most common. I know that CNR sir showed a lot of really good examples, which however they are a little bit less common, I think, for several reasons, but we went with the typical shading, that is the internal shades for now. So here is the first case study. This is a warehouse that was turned into an office in Bentonville, Arkansas. So this study was done in February 28, 27. So this is a south-facing facade. So you have a pretty low sun throughout the day on that facade. So exactly same orientation, side-by-side windows. You can see this is the window with the View Smart Glass. This is the traditional window with the shades fully down. We are showing one image here, right? So you can see the shades are not completely opaque. These are not necessarily the blackout shades, but definitely there is absolutely zero view when the glass is when the shade is fully down. You can't see anything through it. So this is what we compared side by side. So here is the illuminance level chart. So the y-axis here is showing illuminance in lux, which is basically how much light is reaching a surface. So it could be your eye, it could be the table or whatnot. So this is basically light coming to a certain point. And what we find typically is that anything above 3000 tends to start getting into the glare range, anything about 3000 lux. So in the traditional window case, let alone 3000, I mean, it was getting into, it started out more than 3000. It was close to like 10,000 for most of the day. And then finally, when the shades were brought down, it dropped quite a bit. But even that was not enough, right? Because this is a 3% openness fabric shade. You saw that is kind of translucent. So it was not enough to bring the light levels below the 3000. It continued to be that way. Whereas with view dynamic glass, this was well below that, and it was well near the comfortable range in the 300 to 3000, more closer to the 300, which is what you kind of want from a workspace illuminance. And and of course this one and this is fully automated. And the second point is you are never losing any views. All from here onwards, whenever the shades came down, outdoor views are gone, right? But with the view glass, you are never losing access to outdoor views. So that's the illuminance comparison for the study. Let's look at the glare scenario in this. So glare is measured with something called a daylight glare probability, and this is basically a number from 0 to 1. It's a probability. So the higher the number, the worse is the glare situation. So this is an empirical model. This is based on actual field studies with occupants under different daylighting conditions. So here what we see is that, again, not surprisingly, the traditional glass was well above the threshold for disturbing glare, which is 0.4. So it was definitely through that throughout the day. Even when the shades came down, it was still above that disturbing glare limit. With the view smart glass in the tinted mode, in the 1% transmission mode, it never exceeded that imperceptible glare threshold. Here I do see that it has crossed a little bit into the perceptible. The point to note is our product can actually go down to 0.5% visible light transmission. So we did not do it here. So for extreme cases, the glass can be tuned to go to even 0.5%. So if we did that, this problem would also be taken care of, right? So, and then I just want to show you a couple of images from the HDR, high dynamic range photography, that we had taken at this site. This is how we calculated the glare probability metrics. So this one is showing you the unshaded glass at 10 in the morning. You can see DGP of 0.62. So this is well above the glare disturbing threshold of 0.4. With the view glass in tinted state, it's only 0.2. So again, this is actual measured data. We are not doctoring these images or anything like that. This is straight from the HDR camera, and using accepted models, we have converted this to DGP. And then when the shade came down at around 1 p.m., we took again these images. You can see that this is still 0.52. So even with the shade down, you can see that the sun, the sun globe is still coming through. It's still bright. With the dynamic glass, view glass, it's not, it's well within the comfort range. So that's sort of the visual part. And like I said, it's important to understand the thermal along with the visual in my mind. So I want to kind of show you that as well. So we took infrared camera pictures of these two windows, and these are the view angles that we took for the two windows. The idea was to get at least some of the floor surface, because um, here we didn't have any furniture next to the window, so we wanted to capture some of the surfaces to see how much heat are these surfaces receiving, how much hotter are they getting, because this is a very direct indicator of whether there will be discomfort or whether there will be a cooling load, right? I mean, we all understand that this heat is coming in, it has to go somewhere. So I'm going to show you some infrared images, and we basically, what we did is we tracked 2 points on the floor. This is 1 point, this is next to the traditional glass, and there is 1 point on the floor next to the view glass. Point to note is the exterior solar condition is identical. It's the same day, everything is the same. Here what you will see is a sort of series of temperatures throughout the day. So I'm just going to speed up interest of time. So what we found is that between 10 and 12, the floor surface, this is in the unshaded condition in the traditional glass, the floor surface has already hit like 33 or something centigrade, right? This is for a space where the set point is 23. So you can imagine that despite the HVAC working, everything is going on, this floor has already hit, like, exceeded 30 degrees, right? And look at the floor next to the view glass window. It's well within the set point, which is this yellow line. So at that point, we brought the shades down. And so when the shades came down, the temperature next to the traditional glass also started going down, not surprisingly, but it didn't go down as much because two reasons. One is the shade has now become a radiator, right? It's the heat is coming in, the heat is still there. And secondly, because of the thermal mass of the concrete, it's not going to cool down in 5 minutes. Whatever heat it absorbed in the first part of the day, it's still going to retain, it's still going to release. So essentially what we found is that even with the shades down and all of that, the surface continued to be fairly warm, right? And whereas in the view glass case, you see that despite the whole day, right, whatever the solar exposure is, it never really exceeded the set point in the space. So this is my sort of indication that this is keeping the temperatures in the space more uniform. So you can kind of take this and translate this to both thermal comfort and energy savings. Now we did all of that as well, but in the interest of time, I decided not to get into those things. So this is one case study. I'll quickly do one more case study and then just a few more slides. So the second case study is another more conventional office building. Here the windows are on the west facade. So this is even more kind of extreme low sun angle exposure in October. Here are the two side-by-side spaces. You can see that we have put a lot of sensors, very sophisticated studies were done here, and with external help so that it's unbiased. We have collected all of that data. So I'm giving you only some glimpses of this studies that we found. Here the blinds are actually the full blackout shades. So these shades do cut out glare. So once they're down, there is really no glare, but there's absolutely black. So you're not going to see any views, and your daylight will be very, very low. So this is a different kind of a shading system. So just real quickly, what you're seeing here is the average illuminance measured in the room as a function of distance from the facade. So this is 2, 4, 6, 8. So what we see is that for the static glass, the average illuminance for the whole afternoon for the sensors as a function of distance is well, again, above the 3000, like not surprisingly, right? So within the first 8 feet or so, the light is just too much. It's going to be too bright. And then when we looked at the average light levels for the view glass room with the sensors in that room, this is well within the comfort zone. This is 300 is sort of your threshold. It is in that range. And then finally, when you have the shades down, of course, there is no more glare and none of that, but your light levels are significantly down. So the point is, even for view case, I understand that you will need, these studies, these data is collected without any electric lighting in the room, which is unrealistic, right? You're going to have some electric lighting if you're tinting the glass, so that's fine. But the point is, with view glass, you will need a lot less lighting energy to get to 300 versus if it were in the shade case, right? In fact, you'll need probably 4 or 5 times more lighting to get to that 300 threshold. So just to be clear, this is again an energy implication of being able to reduce daylight, or I mean, these are all kind of interconnected. It's very hard to separate one from the other. Quickly, similarly here, the glare, what you see here are, these are what are called luminance maps. This is also taken from the HDR camera. This is essentially showing you the brightness at the source as opposed to the light reaching a surface. This is the reverse. This is how bright is the scene, right? So this is also, there are certain thresholds for it. So we track them side by side. And so starting, there was not much difference, but I'll just speed up a little bit. Around, as you can see now, the sun has started coming in, right? This is the unshaded glass scenario. This is the view glass where it's already tinted. So clearly it's already hit the glare point. And then after that, it's intolerable. It's after that, from about 3:30 to all the way to 5, it's just impossible. There's no way you can sit. So you'll have to pull the shades down, and already you know what the answer to that is, right? You'll have no views, you'll have no daylight. So that's a huge compromise. So this is what we found from the study. And then finally, thermally, similar kind of results. You can see this is the sort of view angle from the IR camera. The nice thing here is we actually had the workstation, so we could actually see the workstation surfaces. So let me kind of speed this up a little bit here. This is the traditional window with the shades down, 1% shades, and this is the view window in a tinted state. So what you're going to see in the graph is the sort of progression of the surface temperatures. Let me just speed up a little bit here. So what the black dot is showing you the work surface temperature, and the red dot is showing you the shade surface temperature. So what we see is that around 4:30, rather around 4:45, the shade has already hit almost like 38, 39 degrees Fahrenheit centigrade. This shade has become such a hot radiator, right? And the surface near the work surface is also close to 30 degrees. This is again in a room where the set point is only 23. So the HVAC is running full, absolutely 100% capacity, but it's not able to deal with this heat. So where is this heat going? It's all going into the HVAC, has to essentially cool up the space, right? So significant energy consumption, not to mention the difference in thermal discomfort for people sitting here. In the view scenario, we see that the rise in surface temperature is very, very little, and it's well within the set point. compared to the other one. So the point again is that with dynamic glass, you're able to maintain consistent indoor conditions, which I think Sienna Rao sir also touched on. It's important to maintain that consistency of indoor conditions, but you're never losing views outside, not even for a minute, no matter what the condition is, how whatever tint state the glass is. So that connection to outdoors, which is very, very critical for productivity, for mood, for reducing eye strain, that is always present with this product. So with that, I'm kind of just down to my last few slides on the project profile of how this glass has been used. I know you might be curious, hey, where has this been used in India? So I want to start with that. This is our first project in India. This is Divi's Lab building in Hyderabad. This has been, this was, like I said, our first install. This is up and running, and it's a slightly older generation of our product, but it's at least something that we can refer to. More recently, we are working on a very, very large building in Electronic City in Bangalore. Belankani Group has building this building. It's about 175,000 square feet of glass, one of the largest installs in the world, 23-story, 1.5 million square feet office building. So this is kind of in the work. So, and like I said, there are several other projects we are working on. So Indian market is very, very important. We want to go after it. Here are some examples from North America. So this is a very interesting design. We have been selected for this project, 70-story multi office building in New York. Then there is this is in San Francisco. This is the Public Works, San Francisco Public Works building where they are going to basically be reviewing and passing plans for other buildings. So we are really hoping that once these people are in this building, they will really understand the benefit of dynamic glass themselves. And here is an example of a kind of a skylight, or rather even a roof system, where we have, this is a retrofit with view glass, and the original product was some Calwall or something, some fiberglass product. It was not able to provide any thermal discomfort, and on top of that, it was degrading under solar radiation. It started getting yellow and everything. It looked very, very ugly. So they completely changed it and put view glass, and after that, you can actually see they actually could put people here. This space was unusable. Now they're able to put tables, desks, everything. People are very comfortable. This is North America's first digital hospital, also has view glass. The patients in the room have access, our ability to control the glass directly from the bedside. We have gotten very, very positive feedback from patients. They're very happy about the way the glass works and the fact that they can personally control it. This is also another first in the world, the largest multifamily install in Virginia with dynamic electrochromic glass. Each unit has control of the glass. The occupants are able to control it themselves. But the point is, this is all automated. Everything is running on automation. But we give the occupants or whoever is in the buildings the ability to change it if they want to. And then finally, last but not the least, one of the largest projects we have, this is the entire Dallas Fort Worth airport. They are redesigning as well as adding new buildings. This is a very, very large amount of glass that they have decided to go with dynamic view smart glass. They've realized the benefit from both an occupant perspective and from a comfort, from an energy, wellness, all of that. So this is kind of the range of products. I will add one point that in India, because the way our product is modeled, we are considering local weather, we are considering the model of the building in the local site. It doesn't matter. This product is not designed for North America or Europe, anything like. It will work in any climate, in any configuration. Just want to make it clear. And then finally, my last takeaways. Just to wrap up, View Smart Glass is a complete product. There is the coating, the IGU, the physical part of it. Then there is a network, which is the hardware. Then there is the control. So I just want to be, the point I'm trying to make it is that this cannot be compared with the regular traditional glass in terms of performance or cost. You have to look at it in a different way. This is a transformative, disruptive product. It's in a different league. So it is not just a window. It is almost a device that people can interact with, right? So it's digitizing the skin of the building. And then I already talked about this. This is a fit for almost all kinds of building verticals that you can think of. These are actual photographs of buildings that View is on. So you can see this is not just for all floor to ceiling glass. There are different kinds of designs, curved, facades, or different building verticals, whatnot. And then finally, my last slide, I want to leave with this, is that what is the real benefit of this product? I think I've already spoken about the fact that you need no kind of shading when you have this kind of a product. There is a 100% connection to outdoor views. Smart and connected, of course, I didn't talk about a lot, but that is part of the IoT features that we'll be launching. Comfort is, I think, by now clear that we are maintaining from both thermal and visual. Energy is just a byproduct of that. This glass is with its low SHGC, it can definitely reduce energy consumption. And then as far as space utilization is concerned, this is just a byproduct of being more comfortable near the glass. This is something that is very, very attractive for developers and other people who want to maximize the rent or maximize the space that they have. They don't want to waste any space. So with a product like this, you're able to put people really close to the glass and maximize the space. But the final two things that I want to kind of leave you with, even if you ignore everything else, is really the impact on health and productivity. And I think this is, again, I'll go back to what CNR sir has touched on. This is the absolute key, I think, point that we have to keep in mind when designing for buildings in general, especially with dynamic glass. Because of the way it's able to modulate the daylight and maintain views, there is a significant benefit to health and productivity. And these numbers that you're seeing are actually from studies that we have conducted with third-party independent researchers, universities. I'll be very happy to share that data with you. So I want to leave you with the fact that this is not just a window, this is well beyond that, and the kind of benefits that it offers is absolutely a multitude out there. And I love to have conversations offline. If you have project specific queries, please do reach out to me. Thank you for your patience, and that's all I had.
Thank you, Ronnie. A lovely presentation. Summarizes today's discussion. We'll take just 5 minutes of Q&A. I'll take one questions for all of us. So can I have Raghavendran sir and Balaji back on, if you don't mind? Hi, Raghavendran sir, are you there?
Yeah. Just this is giving.
No problem, sir. Till you get your thing sorted, I'll take a few questions. I'll just take a few questions for Balaji. Balaji, there's a question for you. What is the density of high pressure laminate if we use horizontal shades and CNC concept? Will it strengthen the issue? Is there any calculation you suggest?
It depends. When we talk about perforated screens, the thickness of the panel will also change as per the perforation levels. The project what I showed you in Kerala had almost around 35% perforation, which we could still accommodate with 6 mm panel. But if the perforations are more, then the thickness will also vary. Normally, when it comes to the density of the panel, it's almost 1.45.
Right. Okay. And is it possible to use the high pressure laminate waste pieces, cut pieces? Because at site there's wastage. Is it possible to reuse HPL?
It is possible. See, normally what happens in many of the cases is we also help the architects or the customers to use it in some other places. See, there are places like gates, there are places like interior walls. Even we have done something in our own office. Whatever waste pieces we could get it from cutout, we used it as interior hangers. We connected it to a small chain link and then used it as a hanger. So it is possible.
Right. Okay. Ronnie, a few questions for you here. What are the size limitations in terms of glass size, warranty of switch, and maintenance? Will there be any glass color variation issues in dynamic glass? And can the glass be curved? So I think these are 3 questions in one.
Yes, okay. So the first one is the maximum size that we can manufacture is 6 feet by 10 feet. That is the current maximum that we can go. We can do different sizes, obviously smaller sizes. There are some restrictions on the angles and whatnot. We cannot actually do curved glass. So if you have a curved facade, we have done curved facades where you're going to break it up into rectangular pieces. That can be done, but the curved glass itself cannot be. If it's curved, we cannot apply our coating. Okay. Secondly, I think there was a question on warranty, right?
Right.
Okay. So warranty
of switch and maintenance.
Yeah, warranty. So first of all, the warranty is very standard. As far as the IGU is concerned, we follow whatever is the standard IGU warranty, at least in the US market, because it's if anything, you would know that if the glass fails, it's really the sealant in the glass. It's not the coating. So our coating has been tested by ASTM, which is the American standard. It exceeds a 50-year life cycle. So because
Right.
there are no moving parts in the product, this is all hard. This is solid state physics. There is no moving parts here. So
Right.
it is absolutely doesn't degrade even after 50 years. So yeah, so we will give the standard warranty, and then I think there are different packages that the customer can offer, offshore if you want a longer. Other than that, there was a question on color. I think color matching, right? Color, something like that. So what I will address is similarly same thing. What we have done is there are some standards where we have to meet in terms of this color between paints. We have very high quality testing in our factory in terms of color matching, and this is something that we rigorously adhere to. So we don't really have that much of a problem. The advantage of this product is that the color can be actually tuned to voltage. So when the glass is going on site, we can do color matching just on the site itself, right? So
Right.
if there are small variations, the voltages can be changed and that can be done. So it's not a major issue. It's not a major issue.
Okay. So Raghavendran sir, are you there?
Yeah, I'm there, but I'll be joining you on audio.
Oh, audio, no
Can you hear
problem.
me?
So no problem. We'll take the
Yeah.
audio. Yeah, we can hear you. We can hear you, sir. So there's one question for you. What are the major softwares to be used for daylight analysis and sun shading analysis?
Actually, I'm not really an expert, but perhaps Ronnie can answer this. But usually the Dialex and the other software that you mentioned, which gives you the illuminance level,
Right.
these are good. Actually, one thing I learned in this whole field is that you cannot practice architecture alone. You have to work in collaboration in teams. And therefore,
Right.
it's a collective kind of progress that one has to do. And you learn a lot in the process. In terms,
Right.
likewise, you also share a lot of knowledge across the board. I think all of us are becoming more and more sensitive to work across
Right.
disciplines. So if Ronnie has to add something, I would request him to add.
Oh, sure, sir. I will. So I think even Mr. Balaji mentioned this probably, but there are tools like this Grasshopper, Rhino. These applications are there that many architects are using. Radiance is the engine for daylight analysis. That's pretty much standard in the industry. And there are a whole bunch of tools. My only advice is that don't, like CNR sir said, that we have to use technology, but I'll say don't be too over reliant on it either. This is coming from somebody who is a simulation guy. But be careful about the results and always question it. Use your common sense also, because in the end of the day, these are software tools. It's garbage in, garbage out. That would be my feedback.
Right. Okay. A question for Balaji. Balaji, weather perforations in HPL panels, do they hamper its water absorption properties?
No, it doesn't, because I can say high pressure laminate panels are homogeneous by physical property. So even even if the core is exposed, it doesn't have a problem at all. It doesn't get delaminated, nor it doesn't get the physical property doesn't get hampered.
Okay, great. Ronnie, a question for you. What happens when there is a power cut?
Yeah, that's a great question. So the natural state of the glass is the clear state. So in the unpowered state, it is in the clear state. So when there is a power cut in the building, if the glass is tinted, if it is tinted, it will gradually clear out. But depending on the size of the glass, this will basically take up to 2-3 days. So it's not, I think I understand the question where maybe they're thinking, what if the power goes out, glass suddenly clears, there is no shade, what will happen to the occupants, right? I think that's the context
Right.
of this question.
Right. Does
So
the glass work? Does the glass electrochromic glass work without electricity if there is a power cut?
No, it won't work without electricity. It won't work. But what I'm saying is that if it is in tinted state, it will lose tint, but over days. So if you don't have power for days, you have other problems in the building, right? Glass will be the least of your problems. But the point is, let me make a quick point here. Because this is such a low voltage technology, what we have found is that a very small backup power can keep the glass running. So you don't, I'll just give a quick example. About 2,000 square feet of windows,
require the same power as a 60-watt light bulb. So if you have 10,000 square feet of glass, we're talking just 5 light bulbs, right? So it's hardly anything. So big projects where there is a resiliency requirement, like hospitals or government facilities or even airports where our glass has been installed, they have connected it to the backup power. So that's one way to deal with.
Right. Raghavendran sir, a question for you. Out of all the projects you have designed, which project is the one which you have been able to bring most amount of daylight inside, and which was the most satisfying out of all the projects you have done?
I think, I mean, quickly off the mark, I would think the work that we did in Mauritius, which
in Mauritius,
which was in Mauritius. This is an IT campus, and in fact, it was put out of an MOU between Government of India and Government of Mauritius. And this IT building had a huge skylight atrium inside, and therefore any offices had an opportunity to get the daylight from both the sides. And the depth of office was carefully modulated so that you did a similar study in terms of daylight analysis. And we had an atrium skylight. Skylight also was designed to see that allowance of daylight penetrates deep into this bottommost point. And the clients were very happy because they never had to switch on a light. Single light was switched on during daytime.
Right. So that is probably your most satisfying.
I think that's perhaps one of the reasons why that global award also was
Right. One more question for you, sir. In other countries, generally people experiment with materials apart from glass. You know, like you mentioned, polycarbonate, fabric. Why in India there is still only people experimenting a lot with glass and very few projects with fabric, polycarbonate, and other materials like ETFE, etc. What do you think is the reason behind it?
The reason I think is the volume and scale, because any product eventually has to be commercially viable for the product person. So if the demand of those products are not very high, then it's going to be highly priced, and the price will rule out the use of the a cell phone is a typical case. The minute it becomes affordable, usage goes up tremendously. So I'm sure this electrochromatic glass, I don't know what the price is, but I do know that it's pretty high. But surely, India became being a very highly price sensitive market. I mean, if Ronnie can think of some solution, I'll be one of the first to use this in my projects. So I think India has become very highly price sensitive, and clients do not want to use anything that's not tried and tested before, because they want to go and see it beforehand. They want to see how it works. They want to talk to the users, and it's a very complex process of decisions.
Right. So I want to add one more
unfortunate thing. One more unfortunate thing is that clients don't trust what the manufacturers say straight away. I'm sure both of you have felt that aspect. They are very skeptical about data which they don't understand. They don't understand. They think it's somebody is failing them. This is a big problem that we have. And even certified labs and all that, not got to be much more testing that's happening to Indian products, so that we know what testing means, we know what certification is, and so on.
Right. Thank you, sir. So Ronnie, we will take last two questions. So Ronnie, for you, how much is the CRI in view glass when sun radiation falls on it? We generally saw things appearing bluish outside. Even for light falling inside, looks colored. So it may look impact the interior looks.
Yes, that is a good observation, good question. I think so. Typically, what happens is, let me clarify in two ways. So CRI, color rendering index, is actually something that is meant for luminaires, for lighting, not for glass. Just to be very clear, first of all, I know that this is used for sort of interior design. So what we have found is that when the glass is in the tinted state, yes, the light coming through is very low, right? At 1% transmission, you're not going to get much light through. So whatever the CRI is in the space, let's say at the on a desktop or something, right? it's going to be completely dominated by the CRI of the lighting in the space, much less by the glass. So let that sink in for a minute. So whatever CRI, so what you're talking about is the glass itself looking blue. That's two different things. The space looking blue versus glass looking blue are two different things. So the glass might look blue, but the space is not going to be blue because that light will be defined. That's the addition of the light through the glass and the light that's coming from the fixture. Now, let me address the blue concern real quick, because this is something that has been a pushback for using this product from a lot of architects, right? I know this. So we have the next generation of our product, which has just been released this month. It has significantly addressed this problem. We have a far more neutral color in the tinted state. I unfortunately could not present any of that within the limits of this presentation, but we have addressed that. So I'll be happy to take this offline and share what that product looks like. But CRI is no longer a problem. We have the most neutral dynamic electrochromic glass in the market now.
Right. Okay. So there are a lot of questions on pricing. I'm not going to take them because I'll send them offline to you so that you can answer to them directly. We'll take one last question. Let me just take this for Balaji. Let me just pick. There are several questions. I'm not able to just sort them out. Right, Balaji, there's a question. What is the maximum allowable wind pressure high pressure laminate can withstand?
See, as a company, we can design.
System dependent, if I'm not mistaken.
Sorry?
I think this is system dependent, right? This wind load.
It is. See, it is not only the system; it is even the panels as well. So if you talk about some of the largest designed ones, I think we have designed a 4.5 kVA wind load project in Mumbai. That was one. Recently, we designed a higher wind load project for Wipro in Chennai through CR Narayana Architects, where the wind load was almost around 2.5 kPa. So the wind we designed. I don't see a limitation in terms of wind load as such, because the panels start from 6 mm, it goes up to 13 mm, even for exteriors. So you call it a cladding concept, you call it a shading concept. We as FunderMax can design and deliver those products. That has been a biggest strength for us.
Right. Okay. So I think that's all with the questions. I'll share them with you guys offline. Can we have some closing comments? I think starting off with Raghavendran sir first.
I think it's a very high quality presentation from, I mean, I would include myself, but both the speakers. And I'm sure there are a lot of take home points that came out of this. And I'm sure it is a lot of people thinking about and also wanting to know more about these products. That way, the organizers should be feeling quite content about what's happened. In fact, should feel a little proud of it also. I really congratulate Zach Group for this. And
thank you.
Time is a problem, and otherwise, the question answer session is a very key thing, so that it brings out a better interaction. But maybe next time.
Right. Balaji.
So as I started, it's been a privilege for us to share this webinar space with the master himself, CNR sir, and Roni's presentation was very good in terms of the information provided, what the technology has to offer. If I'll have to put my end remarks, I would like to summarize on the concepts on how we can bridge the gap between the passive and the active architectural methodologies is what we could see in the overall presentation. It was really good. Thanks to WFM for organizing such a fantastic webinar session.
Right. Ronnie, I think you have a louver killer product. In the future, probably people might not need louvers. So your closing comments.
No, well, first of all, I want to thank you, for the opportunity to kind of spread a little bit awareness about the product. And like I said, I'm happy to take all offline comments and kind of address them as they go. I think that yes, I mean this is definitely while my presentation was around not using shades, but I think as Sienna Rao sir showed, the architect's creativity is not necessarily limited to just one product or solution. So I don't want to necessarily say that there's absolutely nothing out there that. But from our point of view, we feel like this is a product that is, like I said, it goes beyond just a window. That's why I'm not just saying shades is kind of our enemy, right? It's beyond that. We are talking about a device. We have moved on from a window, if that makes sense. So this is not just a window anymore. So that's why I don't want to be just narrowly focused saying don't do shades. Yes, it doesn't require it, but absolutely there might be projects where that's a better fit architecturally or cost-wise something. Absolutely, why not? So that would be my.
Right. So thank you, gentlemen. Thanks for your time. Thank you, Raghavendran sir. Thank you, Balaji sir. Thank you, Ronnie. This is my son. He's now jumped with me on the table because I'm over time. So thank you all for staying back. We had a fabulous audience today. We had around I see a 940 registrations and we had 691 people attending. So it was an amazing audience. Raghavendran sir, thank you for your time, and you were the magnet for such large numbers. So thank you so much. Please stay safe, sir. All of you, Ronnie, Balaji, please stay safe. All our attendees, stay safe, stay healthy, stay at home. Together we can win this battle against Corona. So Jai Hind, all of you. Take care, gentlemen. Bye-bye.
Thank you. Thank you. Bye.
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 Thank you so much.
Thank
Bye,
you.
sir.
Bye-bye. Bye-bye.